Yes. So welcome back to the session number 4. And there, now I have the pleasure to introduce my colleague Jürgen. And it was, I think, at some point in October or November last year when you approached me and said, I have an idea. And here we are now, just half a year later, we've implemented it. And now we want to basically get everyone working and exchange best practice. So Jürgen, over to you and introduce your panelists, please.
Absolutely, but still, Ute, thanks to you because you thought it was a good idea. Otherwise, we wouldn't be sitting where we are sitting now. Mm-hmm. And also to all the panelists and the committee making this happen. I'm forever grateful for that. But before we start introducing anyone with anything, starting the presentations, I would like to ask Cassandra to share a browser with a thank you. So when we're talking interactivity, we have a couple of questions where we would like the audience and the panelists to log into the Menti. You see the web page. So if you open another browser, type www.menti.com and you add the code 79447930. We will come back to these questions at the end of the presentations and the questions and answers session, because there we would like to have some on the move, on the spot input from the audience, so to speak. Thank you, Cassandra. Coming back to introductions, we have Inger Jennings, who is the Access and Logistics Officer at the longest name so far of the institution, Svalbard Integrated Arctic Earth Observation System. That's why we use acronyms within the community. It's called SEOS. So over to you, Inger, and good luck.
Thank you, Jürgen. Hopefully you can see my slides.
Loud and clear and visible.
Okay, perfect. Yeah, so I want to talk to you a little bit about what SIOS does to support logistics for scientists at the top of the world in Svalbard. So as Jürgen said, SIOS stands for the Svalbard Integrated Arctic Earth Observing System. And this is a consortium of institutions that own and operate research infrastructure in Svalbard. We currently have 26 member institutions from 9 different countries, most of them European, but also from 2 countries in Asia. And the purpose of this consortium is to establish an observing system for Earth system science, where we kind of link processes between the lands, the oceans, and all the way up to the upper atmosphere in support of research into environmental and climatic change. So what SIOS aims to do is to take all of the dispersed infrastructure and data that's owned by the member institutions, as indicated by the purple dots on this map, and really bring them together and integrate them into a network of systematic observations and make these data available to the research community according to fair data principles. This will help to advance Earth system models and Earth system science more generally. So I work for the SIOS Knowledge Center. This is the central hub of SIOS and coordinates the services that we provide to the scientific community. And I'm in charge of the Access and Logistics Service, which provides access to the research infrastructure owned by SIOS members and facilitates the accompanying logistical services. I thought I'd include a little bit of historical context for those of you who aren't so familiar with Svalbard. So the location is shown on the map here. Inside the red circle is the archipelago. It's located around halfway between the Norwegian mainland and the North Pole. And until 1920, this was kind of a no man's land where individuals and companies from lots of different countries had established fishing and mining, but it wasn't owned by anybody. Then the Svalbard Treaty was signed in 1920, which gave sovereignty to Norway. But because there were quite a lot of economic interests already established, the Svalbard Treaty also lays down equal rights to citizens from the companies, citizens and companies from the countries that have signed the treaty to access certain economic opportunities. And this has relevance for how Svalbard is managed today. So because of the Svalbard Treaty, for example, there is no need for a visa to come and live and work in Svalbard. We're also exempt from Norwegian customs regulations, and we're a VAT-free zone. So as a result of this, Svalbard is part of the Kingdom of Norway, but is actually outside of the European Economic Area and outside of Schengen. This history is also one of the reasons why we have such a diverse and international research community established here. So as you can imagine, being in such a remote location, we have some specific challenges. We have limited transport options in terms of bringing cargo and people to and from the archipelago. And also, once you've arrived in Svalbard, if you've arrived by plane to Longyearbyen, which is the main settlement, we only have around 30 to 40 kilometers of road, as indicated by the red lines on this map. And if you want to conduct your scientific research outside of this area, then you need to make use of other kinds of transport options. In the winter, you can travel around by snowmobile. In the summer, you can travel around by boat, or as long as there's no sea ice. You can also use helicopters for transport, but this is very strictly regulated. And actually, in general, Svalbard has very strict environmental legislation. Other challenges that we see that scientists encounter is just understanding the legal framework. I've already touched on the visa and customs regulations that are different from the Norwegian mainland, although we are in Norway. And also the environmental regulations, which are in many cases much stricter here than in other parts of Norway. Because of our location, we also have a very extreme working environment with extreme cold temperatures and strong winds, as well as natural hazards such as avalanches, which can occur. And the majority of, well, all of the buildings and roads are built onto permafrost, which also has challenges for establishing research infrastructure here. For visiting scientists, one of the challenges they see is the different procedures that are operated by the different service providers here. I can give one example, as the University Centre in Svalbard has quite strict rules on that the need for safety training when you receive any kind of logistical support from them, whereas other operators have no such requirement. So it can be quite hard for the users to understand which hoops they need to jump through in order to access support. The needs of the users also differ a lot. Some of our member institutions have quite well-established networks up here and their own staff available on site who are able to support the scientists that come. Whereas other smaller institutions, they need a lot of support and need to be able to access those from people that are already established up here in Svalbard. And generally, the number of service providers are quite limited, and that means that there's a risk of insufficient capacity during high season. All of these challenges combine to result in quite high costs for the user, and some of them, the smaller research institutions, have quite limited budgets, and that can be a very big challenge indeed. So the role of the SciOps Logistics Service is to really provide an arena for information exchange for the scientists to be able to talk to each other about their needs and how to access support, to understand the needs of the users and to connect them with appropriate service providers. To encourage logistics sharing, and this is a very important part of my job, as this increases efficiency, saves money, and reduces the environmental impact of science when it's conducted in such a vulnerable environment. And in general, I aim to help to reduce the burden on the individual researcher by trying to streamline and coordinate these logistical support processes. A few of the highlights of what we've achieved so far. We've established a notice board for sharing information about logistical services, where people can, for example, share information about spare capacity on boat transport going to remote locations. And people can also request supports on this notice board to get assistance from technicians and scientists that are already established in Svalbard. And this has been especially important in the last year, as we can see in this video that I might have to, sorry, I have to share again so you can hear this sound.
Due to pandemic situation and travel restrictions, we couldn't conduct field work in southern part of Svalbard, near Polish Polar Station at the beginning of hydrological active season. It's mean in June of this year. Finally and fortunately, our expedition in the frame of the ongoing national Polish project called Indicating and Projection of Hydroclimatic Condition of Southern Spitsbergen was organized thanks to help and support of SciOS and UNIS, so we avoid gaps in long-term data series. Yeah, it's possible to organize online polar expedition.
So hopefully you could all hear that well. So that was a very nice example of how we were able to provide support in a very difficult situation. We also have just general information to scientists on the web, where we try to collect the most useful information about, for example, cruise plans, vessels that are available to charter, offers that are being made by SciOS members for other SciOS members to access. We also conducted during this pandemic a virtual meeting to help scientists to navigate the very difficult hoops to jump through in order to actually reach Svalbard at this time, then where, you know, with having to do testing and quarantining en route. And we're currently establishing an e-learning for Svalbard research, which will help the scientists to navigate the legal and logistical landscape in Svalbard and collect all the information in an easy to reach place.
Due to pandemic situation.
In future, we hope to work more with our members to improve coordination of the services and provide easy access for users. For example, through a unified kind of booking system, a one-stop shop for logistical support, if you like, where the kind of access to services is standardized and easy for the scientists to help reduce confusion and improve efficiency further. That's all I wanted to say, so thank you very much for your time.
Thank you very much, Inge. It sounds like a remote heaven where you have no VAT or customs duty at the same time that you perform magic without budget, and that's impressive, really. Ben, so you're head of transportation group, Fusion for Energy and ITER. The scene is yours. And do unmute.
Unmute, found it. I'm not a specialist in Zoom, but I deal with transportation and logistics. Good afternoon, everybody. Thank you, Jürgen, for introducing me. My name is Ben Slay. I am the head of the transportation group. I work in Fusion for Energy, and I started there in 2008 in Fusion for Energy, and I work on the ITER project. So I will take you through some elements to explain what the project is, and then I will come to some transport specific things and our challenges. So I will start by what is fusion. You can see the slides passing, it's working well, thank you, Jürgen. So I'll start about what is fusion, then our organization Fusion for Energy and our contribution to ITER, and then I will jump to transportation and challenges. So we start by what is fusion. And fusion, in fact, it is the most common form of energy in the universe. It is the process that powers the sun and all the stars. And it occurs when light atoms reach a very high temperature and under certain pressure. And this process of fusion releases enormous amounts of energy. In ITER, we use deuterium and tritium. Then fusion is not new. It has been, for decades, has been worked on, and research has been done since, let's say, the 60s. So there's over 60 years of different projects. And ITER is not the only one, but it's quite a big one in the field of fusion research. And I will show you also a bit of history there of some of the fusion projects. You can see JET. It is a project based in the UK, and there is JT60 in Japan. Then you see ITER, and in the future we will move to demo. JET is in fact one of the, it's a remarkable project, because from that success that was achieved there, Ronald Reagan and Gorbachev decided to join together, and this was the starting point of the ITER project that came from this beginning. ITER, it means the way in Latin, and I will not go through all the slides, but what the idea of this experiment is to generate 10 times more energy than we put into the machine. And then there are other things that you can see on the slide that we will look into. The ITER project, just to give you an indication of the size, it is the machine, it will be 3 times the weight of the Eiffel Tower. We have about 10 million components, which is, if you see that an Airbus 380 has around 1 million components, you can think about the size this project has. And the tokamak complex, which is, let's say, the center of the experiment, is where the fusion process will take place. It has a weight of 400,000 tons. Give you an order of magnitude of the cost, it can be compared to an Airbus A380, but also to Apollo, and it's not in the range of the ESS, but you can see where it stands. It has a significant cost, this project. So ITER is located in southern France, in Cadarache, 100 kilometers above Marseille, and it constitutes of the world's biggest economies. So we have Fusion for Energy, it's Europe. Our headquarters is based in Barcelona, in Spain. Then there is US, United States, there is India, there is China, there is Korea, there is Japan, and the Russian Federation. These are members that contribute in kind and a little bit cash contribution for the ITER organization to do their coordination and assembly of the machine. But these in-kind contributions, these are manufactured all over the world, and that's I will come later on the logistics part for that. Now I'll jump to Fusion for Energy and its contribution to ITER. FRE is a public organization set up in 2007. We are established for 35 years. We have offices in Cadarache, France, in the ITER project, but also in Garching, Germany, and in Japan for the broader approach project. We have in the order of 500 staff, and our budget is in the order of 12 billion. Then the European, because the project is located in Europe, the European Domestic Agency, as we call the members, Fusion for Energy, it contributes about 45%, and we do all kinds of, in all the fields of the entire project. So that goes from superconducting magnets, but also to neutral beam injectors, cyclotrons, these kind of things. Besides the contribution to ITER, we do other developments, but today I will keep it short and focus on just ITER and its logistics. And then I will move to transportation and some challenges. I will explain you what kind of, out of these 10 million components that we have, I will show you what type of components we have and also the special measures we took for some very big components. And I will show you a bit of history, and then I will speak about the main challenges we have. So the ITER organizations and all the domestic agencies, all the members, we signed one framework contract with Daher, our local service logistics provider, and they also take care of insurance. We signed that in 2012. And with these 10 million different components from all over the world, well-coordinated logistics is a must. We have contract conditions for competitions and optimizations for offering these services. And what we also have is flexibility. We have contingencies for last-minute deviations, and we have incentives to share savings. But also, if someone sends components from India and they send them through the smaller components, they send them through the service, the logistics service provider. Then Europe pays for the last part to bring it inland. So that is an incentive to also use for the smaller pieces, our logistics service provider. And for the bigger pieces, the biggest pieces, it is an obligation to use the service provider. And I will explain you why. You will see it from the pictures coming. So we have three different dimensions of loads. We have standard loads in the lower part, which everything that can go in a normal truck. Then we have conventional loads that need a pilot car and a permit, but that are still can go on the normal roads. And then we have highly exceptional loads. And these are loads that cannot go on the French classic roads, but they go on a special built itinerary, which has a total length of around 100 kilometers from the port to the project. Here are some dimensions. The main thing to remember is that if something is roughly bigger than 5 by 5 meters and 20 meters long, and with a weight of 60 tons, it becomes in the category of HCL, and then it meets these special measures and night transportation. So we have around 220 of these highly exceptional loads. And here you can see on the map, you can see the road we travel from the ocean port on the Mediterranean Sea close to Marseille, and then we take a barge, we cross a lake, and from then we take this 104 kilometers of special road. It can take 1 to 4 nights. It depends a bit on the dimensions and the size and the center of gravity of the components that are shipped. So we started in 2008 from 2011 to adapt or improve existing roads. And I will give you some examples. Here you can see a bridge crossing the highway, the Route du Soleil in the south of France. And the bridge, the existing bridge cannot handle the weight. So we built a dedicated detour. The same for difficult curves and bends. We built a dedicated dock to receive the barge that takes the components from the ocean carriers into a smaller boat to cross the lake that was in the map. We have changed roundabouts. This is just an example, which we cut in half so that big trucks can pass. And also you can see much more in this YouTube link about the history of this itinerary. When all the things were completed, we had 2 test convoys in 2013 to make sure that the capacity of the bridges and the whole itinerary worked for the maximum dimensions and the maximum weight. And then end of 2014, beginning of 2015, we had the first component. It was a heavy transformer from France, which is in fact one of our lightest highly exceptional loads, and it was transported during one night. Here's another example for something manufactured in Switzerland by Linde. Then we go through 2,000 kilometers of canals all around Europe and rivers to get to southern France. Here you see an example of the barge crossing the lake, taking some components from the ocean to the inland dock. Here you can see a colloidal field coil, which was manufactured in China. It is 11 meters wide. The total transport is about 800 tons, and it takes about 4 nights to cross the 100 kilometers. And another example is a VV sector, which has a total weight of the convoy of 900 tons. And on the right-hand side, you can see the component arriving during the night at the construction site. That was just to explain a bit what we do, and now get to the main challenges to get these 10 million pieces over a period of 15 years in the right place, in the right time. It is extremely important to get the whole long supply chain on board to work in the interest of the overall project. And that means the manufacturer, for example, in India, the supplier in India, up to the final user, the ITER organization, and all the steps in between. Just to explain, if someone wants to get things out of the factory, they just package it and they send it away and then it's done. But in the end, we might need to store it for a longer time. We have to handle it in an efficient manner. So these are quite important things to consider the whole chain and the whole project. We need correct input on dimensions, weight, locations, and pickup dates to allow for optimizations. It is, as you can imagine, by a big project, Sometimes scheduled dates and things, they change a lot. So we have to be very flexible and proactive. Proper packaging and clear instructions on handling, storage and preservation are essential. And another thing, it was mentioned today a couple of times already, timely and complete input for custom duties and tax exemption. In our case, we have a direct access to the French system, but we have also components that are first brought to other countries in the EU and then further manufactured and delivered. And then it is a bit more challenging to find the right people and the right explanations in due time. I will come to my conclusion. I put some remarks that I'd like to share with you. In my view, it's important to have one project-wide global logistics provider for a long-term project, while this enables improvement by timely sharing lessons learned and avoid repeated mistakes. For us, we are running a project for around 15 years, and then if you have a lot of changes in your support, that is not very useful. There has to be a willingness and proactive management to implement improvement and flexibility in contracts to act fast. So as I said, we have contingencies in our contract. So a project manager, by one little email or a telephone call, he can give an instruction. If something happens during the night, unforeseen, or things happen at the airport, and we can take immediate action. And I think their research institutes, we have quite heavy procurement procedures, which do not allow for very fast acting, which is required in transport and logistics. Then another one, it's logistics is a project, not just an administrative act. So you have to put it in a proper place in your organization. For example, in our case, we are in the technical department in an engineering support unit. So people are used to seek advice on specialist items like earthquakes, like seismic analysis, but also for transportation. They know that they have to go to this technical support unit. And then very important that you have clear procedures that all stakeholders commit to. In the ITER project, we have a delivery readiness review. It's like a gate phase where our logistics service provider, as well as the ITER organization, who are the coordinator, they do a final check before shipping is allowed, which is a very big important step in our project. Here you can contact us, and I would like to thank you very much for your kind attention, and hear you later in the question and answer session.
Ben, thank you. It seems that you have overcome the most obstacles, so that would be nice to hear some good practices then later on. But now, Cedric Garino, you're the group leader of services supply chain at CERN. Over to you.
Yep, I cannot share.
Yeah, you have to stop.
I need to stop. Okay, can you see my screen? Yeah. Okay, so I'm Cedric Garino. I'm in charge of the group named Services and Supply Chain at CERN. So we manage campus services such as catering, hostel, mobility, cleaning, all this stuff, and also logistics and supply chain. So I will share with you our experience to integrate lean culture in our internal logistics services. I have only one slide about CERN as a general, so pay attention if you're very interested by CERN. So CERN, we are really a chain of accelerators. The biggest one is the LHC, 27 kilometers. It's really across 2 countries, which is a bit special here. It's between France and Switzerland. CERN is funded by 23 member states and 8 associated members for more than 1 billion per year as a budget. We have normally 10,000 people on site, a little bit less right now, over 100 nationalities, more than 600 buildings, 57 kilometers of tunnel, 53 kilometers of road. So it's like a small city or big village, the way you want to see it. Now I will dive directly a bit on the logistics and share a bit our experience. So this is our internal material flow. I won't go in details because that would be too long, but just to express a bit what operation and services we have. and what resources we have to manage them. So of course we have an inbound flow which is higher than the outbound flow because we mostly construct stuff, assemble and construct. So everything, we have a shipping team which is a CERN team handling all procedure and documents for this import and customs and fiscal files. Then everything goes through our goods reception. We have one in France, one in Switzerland. So we have two options here. Then we have a flow where it's non-standard, so it's delivered directly to what we call internal client here, or it's standard material, and it goes to one of our stores warehouse with some quality control. And then we have an e-catalog available through all CERN community where you can grab everything you need. And we do the pickings and we do the delivery. So we also have this outbound flow where we prepare all documents and organize transport. And we have also movement internally at CERN. We have long-term storage, what we call long-term storage. It's more than 20,000 square meters of storage for accelerator equipment. I think we can build another accelerator with everything we have in our storage, probably. So we are 15 CERN staff, mainly in the shipping, in the management, and also for standardization and referencing for the CERN stores. And all the field activities are handled by industrial support, meaning, and also the replenishment actually. So I will talk about lean methodology, which is something we introduced a few years ago in our internal logistics. So just one slide to explain what it is very briefly. So really the idea to maximize the customer value while minimizing everything we can call as a waste. So it could be stock, it could be delay, useless transport, sorry, defects, everything like that. So that can be pointed as waste. And it's based on two pillars. So continuous improvement, there's a set of tools available, very classical tools. I'm pretty sure you all know about them. And it's also the idea to really engage the frontline workers, so in the process. So we target to evaluate and change the culture at CERN. So it takes time. Usually we talk about 2 years, 3 years to really change the culture and to make sure that works. When everything has been replaced, the culture raised. So that's an indicator it works. So this is a bit an highlight of our lean journey. So we start in 2017. So there was a lot of training. We trained everybody, every drivers, everybody on the field working for us on the site was trained on lean foundation and lean principles. We also train all the management, the field management, and also the higher management. We also invest to have like black belt at the top level for lean training, one person from CERN and one person from the contractor. In 2017, we also redefined all the KPIs and how to visualize them. That was an issue. Nobody was really aware about the target and the KPI which we had at that time. So that was all redefined. And we also implement a parcel tracking tool internally at CERN because we were losing data across the chain of operations. So that was all set up in 2017. Then across the years, we did a lot of workshops. So it was real investments and dedicated days investing and collaborating to solve problems. So there's different type of workshops we organize. It was even in the office, not only in the warehouse or on the field. We also define a catalog of standards, which is the best known way to execute an operation, and also different audits to make sure the standards are well followed. We also deploy tools to solve and analyze problems, PDCA, plan, do, check, act, and also multi-level animation, I would say, what we call short interval management, which are short meetings to really try to solve the issue at the right level and not really escalate all the time all the problems. And we also, from 2018, we also changed a bit our contracts to align a bit our objectives and make sure that we all look in the same direction. So it was a contract where we pay per hours, and it has been changed to an activity contracts where we pay per activity with bonus-malus principle based on the KPIs. And all the experience we gained was also put in the new technical specification for the new contracts. have a few pictures just to explain. It was really one before after. We also redo the floor, so it's a lot better now. But a lot of small ideas, they really came from the field, from the people working on the daily basis, and they came with their idea, and we support them. And we rearrange the space and the floors, and we took benefits, which was on the flow, of course, but also on the safety aspects and ergonomic aspect. All this was considered. I have also a quick example of the sort of standards we've done, which is also shared across all people working really on the field. So that's very simple, of course, but it's very visual as well, and it really helps making sure that we have the best known way to execute a procedure. And I have also an example here of the audits we do to make sure this is really well implemented, and it continues along the years. We also, since we had a lot of data getting from the traceability, we have now at CERN for all the goods delivered and also for the sensors preparation of material. So we can follow almost on a lively manner where we stand in terms of KPI or backlog, or average time. Sorry, it's all in French, but this is super useful, and this is also shared across all people working on the chain. So this is not only for management, really people in the buildings, they also have access to this information, and they can actually take decisions based on that. So it's very factual, and when they do something, they see an impact. So that's really important. For us. One of the main KPI we've defined is really the experience of the internal clients here at CERN. So it's the time, elapsed time between he asked for something at CERN store, so something arrive at the dock in the goods reception, and this time between this reception and when it's delivered internally, we agree that 8 business hours was the longest time to get this service, and we monitored this and the percentage of this service rate, and this is something we really put in the contract and we really follow on a daily basis. So that's a bit what you see here, and it could be cut also by operation, so by many dimensions. I go quickly because I have only 10 minutes now. That's a bit the results of it. So we plot here. There is a plot of all the internally distributed material or parcels along the months. So you see the effects of COVID here, for instance, and we also plot here the service rate. This service rate, everything delivered in less than 8 hours internally. And you see a trend that is which is positive. So we really this continuous improvement has results, and we can measure that along the months and the years, which is good. So now we are between 80 and 90, which was a bit the target. So this is fine. So we're happy for that. And then we also have the service portal, which is ServiceNow, where everybody at CERN can give feedback to a service. And it's a good way also to capture where we stand in terms of what we need to provide as a service. So you see that when we start implementing Lean methodology, we had a peak of satisfied feedback in 2018, which was super nice. And then you can see that the very dissatisfied and dissatisfied feedback decrease over the last year. So it's not just one moment, it's really something we try to continue and really implement as a culture. And that's it. I think I was fast, but voila, that was a bit the sharing of one of our experience at CERN.
Perfect, Cedric. It seems that you have a lot of good practices built in that we would like to share later on. Perfect. Thank you very much. Then, Terje, back to Svalbard. You're the Strategic Development Manager at Pole Position Logistics, and I'm keen to hear what you are filling the days with.
We will try to share the screen then. So you see the full screen now of the...
Can you see the screen?
Perfect.
Right. Okay, thank you. Hello to everyone. My job is to present the best practice at ITER. I'm in charge of the transportation project for DAER.
So let's see here, Francois. I think it was Terje first.
Yeah. Can you see my screen now?
Yes,
or
I
do
see
you
that.
have? Okay.
You do. Loud and clear.
Okay, good. Thank you. I'd like to start with changing the view of the world a bit and place the center of the world in the right angle. And it's of course the Arctic, and this shows the operational area we work from, a bit same as Inger was into. And this proves also that Svalbard is not an outpost, it's one of the most central places in the world. And we call it a logistic and Arctic hub. And this is not only a geographical position, it's also connected to the fact that we have quite an advanced society placed on the top of the world. Our story starts as a ship's agent, and as a ship's agent, you are sort of the one contact the vessels has when they operate in our regions. It's quite much traffic up here. We have these overseas vessels we are handling, large vessels up to 300 meters with more than 3,000 passengers on board. Some of them are selling trips with guarantee, polar bear guarantee, and then of course they have to handle their own polar bears. But we also have the expedition cruises and the science vessels. And expedition cruising is smaller vessels with a higher level of content, I would say, and lots of scientists works on board these vessels as well. Yearly, we are handling 300 to 400 ship calls during a period of 3 months, actually. So it's quite hectic, and we need a system to handle that. We also work more like field logistics, supporting, here we are up at 89 degrees north, close to the North Pole, together with a Russian company. And they are also using Longyearbyen as their logistical hub. Sounds weird when you consider the fact that Russia has the biggest border to Arctic, but it is based on the fact that we have extremely good infrastructure and a well built up society. So I will then go into a bit a nerd section, and most of you panelists are aware of this, but maybe not the attendees. When you hear about logistics, this is mostly the thing people think of it as. It's an order, there is a transport, and it ends up into your storage. But when you work in remote locations, there is a much more bigger value chain, so to speak, before something is produced until you have it on your door. And in our branch, we work, our common language is the Incoterms. So when you order a book on the internet, you actually are telling the supplier or that you are buying something DDP, delivery duty paid. And this is clearing out where is the buyer's cost and risk compared to the seller's cost and risk. So when you buy a book, you tell the supplier here that he is in charge of all the things going on during the transport and transactions. And you can then change, I will not go into details of all of this, but it's important for me to point out that on the other hand, you have the X works. So what we realized when we should try to get in control over the cargo situation at Svalbard for our clients, we needed to dig into the value chain, and we instructed them to go all X works, and we took care of all the movement and did the bookings and took care of all the documentation of it. So let's start with the value chain then. Many think that the logistic value chain is in fact that you go to an integrated logistic provider, and then you get the custom and formalities documentation, you get the transport, and you get the track and trace function. While the value chain, from our point of view, is much, much longer. It starts with a need before it ends up into a delivery. you need to choose a product, you need to choose the supplier, there is a purchase order to be taken care of, and the order confirmation makes sure that you get the time of delivery right, and then you need to follow up the suppliers, you need to follow up the transporters, and then you have the transport-led link, which I was showing previous, and then it could be a second company doing a storage, and you have a third company doing distribution, and you have a return shipping. In science, there is a lot of samples going back and forth, and there is also science equipment to be returned back, and this should be handled in the right way. And you need actually an invoice you can understand. That's not a typical always the case in the logistic branch. And maybe also you need to give some info and statistics. If you look into the roles, you have the guy with the need, the requisitioner. You have the purchaser, or in this case for science, it could be a expedition leader or people in charge of a science project. You have the suppliers. You have sometimes when things are to be paid, there should be a dialogue between the financial people, the purchaser, and the guys with the need. You have the cargo company, you have the terminal operator, you have the truck company. You have, again, when the final invoice is to be paid, a new dialogue. My point here is to show when this value chains start, the picture gets complicated and blurry, and you lose a lot of information. And that is what we try to change, that you need one contact point that can take care of it. And this is based on best practice from the Arctic, that we needed to do this to get in control of it. That doesn't mean that you need to deliver all your needs over to one company. For some of our industrial clients, they are keeping their purchase department. For shipping, they just give us the needs, so we can get a big order of we need a new anchor, 200 kilos of tomatoes, 50 kilos of mayonnaise, and then transfers and stuff, and we do all their ordering, and we put everything up in one invoice. But we also have can offer smaller deliveries. The key thing is the system platform we built, because here what we can offer, what we realized was important for the clients was to have an idea of what was going on, a bit more than just the track and trace function. The track and trace function is good if you only have one supplier, but in project, and especially in science projects, there could be a huge amount of suppliers. So it's difficult to find information. We try to gather that information into one system. So our clients get their web client to go in and have a look. They can go into details on each order or on each project or on each under project connected to a main project. And then we have functions where you can have chat directly into the order, which gives a clearer picture for our clients. Thank you.
I need to unmute too. Terje, that was kind of amazing, sitting on top of the world, to have that one-stop shopping from order to I will come back with questions, be sure. But going on to Francois, the ITER Director of Transport for the project, Director for Transport for the project Daher. From Daher, the Director of Transport for the ITER project. That's most correct. I was, still in Terje's presentation mode. And you're unmuted, so you're ready to go.
No, I'm unmute. That's fine. It seems that the previous presentation is still on. Can you see the screen now?
I see the Windows screen. I don't see the presentation.
I think this is still Terje's screen. He has to unshare.
Ah, okay.
Is it better now?
Nope.
No. Okay. It seems that some other participants is sharing the screen already. That's what the message I have on Zoom.
Okay, now I think that Terje just unshared, so it should be ready.
Okay.
Now we're on.
Is it better now?
Perfect.
Okay, so the subject is best practice with ITER projects. If you don't mind, we quickly share some their presentation for those who don't know the company. Then what we do for ITER in 2 minutes as well. And then we go to the heart of the presentation, which is the best practice, which I picked up the control room. And in that direction, Terje, the previous speaker, already made a very nice introduction to what I'm going to talk about. And then I will conclude in one slide.
François, is it possible to go to presentation mode? Because I think we have the not the full screen of the.
Okay, let me try.
Is this PDF or PowerPoint?
This is PDF, I guess. Yeah, this is PDF. I put it on full screen now. Do you get it?
Yes.
Yeah. Okay. So there is the family ownership group since its creation in 1863, about 160 years ago, in Marseille, France. Historically, it started as a shipping line. Today, DAER is defining itself as a firm designing and developing value-added solution for its industrial partners. So we are right in the industry, no in the B2C, only B2B and industry. We have three main sectors of activity, which are aircraft manufacturing, with the Mark TBM, which is fabricated in the southwest of France. It's one of the world's fastest single turboprop aircraft, which is mainly sold in the US. Then we have also, for the last 2 years, we are producing an aircraft in the US called the Kodiak 100, which is more an all-terrain multi-purpose aircraft, which is used around the world by air taxi operators, pilot owners, humanitarian organizations, kind of things. And in the same division, we also work for maintenance, repair, and technical monitoring of a variety of aircrafts for the same kind of performance and size category. Then we also, in the aircraft industry, we produce aerospace system, aerostructures, mainly with advanced composites structures for aircraft, mainly for Airbus and Boeing. And then the last sector is logistics, which is the historical factor sector, and this is for securing management for all our parts of supply chain for our clients during flows and life cycles. For major industrial programs, and we also in this division work on largest industrial projects around the world. And this is actually my job for the last 35 years, and that's currently at the head of ITER Projects Logistics for ITER, for ITER. And I work with Bensley, with one of my best clients in fusion for energy. In terms of big key figures, it's about a company with about 10,000 employees, about 1 billion euro. It's the interesting thing is, original thing is we share our activity between 50% with logistics services and 50% with industry. So it's quite a good share of business and allow to go through different cycles of economy. We have one Dare Lab, which is very active because it's a company dedicated to innovation. That's about it. So what do we do now for ITER? For ITER, we do international logistics at first, which is presented here as a door-to-door logistic provision. As Bensley was presenting, we have 7 ITER members: China, Japan, Korea, India, Russia, Europe, and the US. And these members, talking about Incoterm, as it was presented earlier, are in charge of delivering in DDU, I mean, from their factory up to the site without the customs operation. They have to deliver their share of ITER components to the ITER site in southeast of France. And we do operate for these 7 members. Then we also do the global flows supervision, which was also presented by a previous intervenant. Thank you. But on that side, I will go a bit further in the presentation because it is part of the best practice. We also have the exclusive use of the ITER itinerary, which was built by the host country, France, to welcome the huge components needing a specific access to the sites. And through a set of conventions with the different regional stakeholders, we have the exclusivity of this, the use of this itinerary. We also manage the PIC, so-called PIC, standing for Protection Important Components, which are a category of components that are specifically followed by the French nuclear safety authorities because of their critical aspects in terms of safety for people and safety for environment. So this is very specific to nuclear. We also are in charge of securing all operations, meaning risk management and risk mitigation processes, because in this specific project, ITER, we talk about first of a kind components. We talk about prototypes. It's a project which has never been built before. So most of the components are not on-shelf components, but very specific, and we need specific procedures. We also take care of the centralized custom management. As a matter of fact, ITER project has the status of an embassy, which notably confers an exemption of duties and taxes. And we have two supervisory ministries, Ministry of Foreign Affairs and Ministry of Budget. So for this, for dealing with these 2 ministries and avoid delays and so on, at the early stage of the project, we together with ITER and other parties, we designed a special electronic link with these 2 ministries that allowed swift and fast customs operations. And finally, we also are in charge of the insurance. We have a policy covering up to 5 billion euro cargo insurance, which covers the risk of transportation between the factories from various countries to the sites. So we administrate also this insurance policy. The other part of our job with ITER is also to, that came a bit later, to ensure the on-site logistics, because flows of cargo are coming in. The project itself was a bit delayed, so we had to build quite a network of warehousing, whether in the port, whether on site. Altogether, it's about 40,000 square meters of warehousing, in which we ensure the reception control, classical, the entry into storage, preservation, because sometimes it's being stored for years. So the components have to stick their original quality, inventory, permanent inventory, and of course, issuing eventually to contractors. So that's what we do for ITER. Now, The best practice I wanted to introduce today is a DIA control room. At the early stage of the project, in the so-called planning phase, and most of you are aware that in a big project like that, 90% of the success of the logistics is standing on the preparation, what we call the so-called planning in English, planning phase. And the question was to say, how do we intend to succeed when we have to deal with 7 different contractors all over the world, hundreds of suppliers, about 10 million components, highly exceptional loads, 300 technical requirements, nuclear safety requirements, well, a lot of different things that we had to plan. So we had 2 main answers to that. The first one was to build, create, design an exhaustive transport and logistic global plan, which took us about 18 months to build, encompassing all processes which would prevail during the execution of operations later on, and an adapted control room which will monitor all administrative and logistics flows, as well as safety surveillance and risk management. So my today presentation is not on the transport and logistics global plan, which is very interesting as well, but rather on the control room, and you can see a picture of it on the screen. So when we built this control room, we were expecting a few qualities of it. First one was to be aligned with ITER organization main requirements. When we talk about ITER organization, we also talk about the 7 members of this organization, which all had their input in these requirements. So it was very important for us that the control room would follow and be aligned with these requirements, not the 300, but the main ones. It was needing to be integrating both administrative and the physical flows in real time. It needs to be homogeneous to the world members. So the idea was to create one single tracing and tracking system. Because it integrated a certain amount of different aspects of the projects, it had to be open to other IT applications, such as custom, clients, IT applications such as smart plants, marine tracking, and so on. It had to be visible by all actors in real time through internet system. It had to integrate risk analysis, risk mitigation, and of course, follow-up of the risk during the operations. It had to provide KPIs in real time, for instance, for arbitration. If we feel that at some times the timing for such a delivery cannot be performed, we need to arbitrate different modes of transportation, for instance, go from ocean to air, these kind of things. And of course, KPIs for the measuring ultimately the efficiency of our practice. Just an example of the administrative process, because we know the shipping process. We have a lot of specialists around the table and in the audience. Administration for ITER was proceeded very clearly, so we had to follow their mapping of administration, which goes from the issuance of a technical information, which has to be very clear, accurate, precise, talking about center of gravity, exact dimension, exact mass, and so on, acceptability to deformation for big components. So this technical information is one phase. Then from this phase, once it's done, we were going to issue a shipping plan of loads, which is evaluating scenarios of routing all over the world to the sites, as well as a quotation for one of the concerned member, and as well as a method statement for big cargo, or not only big, but also very sensitive cargo, let's say. And then out of this quotation and this technical approach, then we could receive what we call a task order and not a technical order, as it's mentioned here, from the concerned domestic agency or their supplier, if they wanted us to go directly to the supplier. And after this task order, then we can proceed to the normal course of planning a shipping operation, which is booking vessel, booking trucks, booking planes for eventual transportation. And then when this administration is done, we go to actual shipments. But just to give you an information, which can be clear for you, this stage of administration process can take, let's say, minimum of 3-4 months for ordinary cargo, but can go to 9 or 10 months for big, largest shipments or largest components. And so in the control room, the KPIs we follow on talk about these different phases: planning phase, warning points before shipping, and then ultimate operations. You can see on the left side of the screen the flags which represent the members. You can click on one flag, it will abandon all the operation, and then you can go on the specific operation, find the shipment, find the component, and find its status in the control room. And then warning points warn us about the density of the phasing of our operation, and then follow up all operations which are on the screen. Take a number to 10, 20 to 30 to 40, means the different stage of the operation from the factory up to the site. In the same control room, during night time, we also follow on the itinerary our big, large transportation. Bensley earlier mentioned this itinerary and the use of it only for heavy, highly heavy loads, going from 80 tons to 800 tons, let's say. And so in this control room, we can follow, thanks to the cameras on board trailers, which film the evolution of the trailer along the itinerary, that allow the officer within the control room to have a clear picture of what's going on the itinerary. Trailers also embark a GPS device that allow quite accurate geolocalization. And this geolocalization is compared with a planned journey, which include the points of interest in the screen. These points of interest are geographical points which have to be crossed at a specific time during the night. So we follow it, let's say, nearly meter after meter, all along these 1 to 4 nights transportation according to the size of the convoy. And this control room is linked to the police authority in Marseille, which is the nearest big city. And with the police authority, we can take the necessary measures in case of incidents, or at least, even without incidents, we can activate alternative routes, allowing the road traffic for the drivers to be diverted. It's kind of example what we do in the control room. That's what you can see on the screen. It's a bit less visible because it's a night picture, but at least we can see the evolution of the convoy during this journey. As a conclusion, I will share with you that a mega project like ITER means dealing with complexity due to long lasting. We go for 15 years at least, multiplicity of actors, complex environments, non-recurrent flows, huge quantities. And to deal with that, we felt that a robust digital solution is not even an option. It's just crucial. We could not deal without it. It must be robust enough to lasting for the duration of the project, and also have to be, in the meantime, adjustable, because things evaluate and we need to adjust our processes and our control and our also IT applications. And finally, has to be aligned with the project members' interests and their own processes. Thank you for your listening.
Perfect, Francois. Thanks. It seems that you're on top of things, and that's good. All right. There are some questions in the feed, but I think we should go to the Menti to see if we get some interaction from the audience as promised. And that goes for you, the panelists, as well. So if you haven't logged on, please do so. You got the web page and the code in the feed of the session. It's in the chat, I think. All got it? Menti.com, and the code was 79447930. And while you're thinking and writing, I can give you some takeaways from the earlier sessions that we've had today, and they're really from hands-on to more technical aspects. We have DVAR handling. How do we do that? How do we make sure that the right DVAR comes in return to the right shipper, for example? Logistics, to some extent, is still paper and pen. How can we avoid that? Communication, that's basics from much success, but it's really hard to get the right data from some players, so to speak. And if best practice is to be found within industry, how do we transfer that? How do we grasp it, and how do we implement it, and how do we make it our standard, so to speak? I see there are a lot of things coming up here. Which is good. Just reflecting on that, yes. So someone has developed some import processes that would be nice to have been sharing, because that is an issue. One service provider, cost plus fee. Now, all of this will be fed into the continuation of the RI.Logistica project. So this will not be forgotten then. I think there is more that's not fitted on the page that we're looking at, and that will be summed up. And we will use this to form an agenda for the way forward as well. That sounds good, yes. Anyone in the panel want to comment this as it stands before we move to the next question? Well, you feel satisfied like I am, so we can continue to the next question. Now, this is looking from outside upon us. I mean, are we complicated to work with? We don't think so. We are just not the same as industry, or are we? So what do we believe the experience is? I mean, Francois, fire away. Are we complicated, or are we straightforward? Just write into the Menti.
Can you hear me?
Loud and clear, but you can write into the Menti.
Okay. So short answers. Okay, you need. I don't talk. I just write, right?
Yes. Because then we can save it, and we can come back to that as a feedback to us. Now, the
Okay.
experience from our side is that we are often misinterpreted by suppliers and forwarders, and we're not talking the right language. And perhaps also it's us not being clear enough. We need to, let's say, face ourselves there. Or perhaps create a common nomenclature that we can use interacting with forwarders, for example. Now, I should have asked you to write a name or something so we know who is writing what, but still the input is important. So
maybe you can read it out, Jürgen, then also the people who
read out the Menti. So we have the complex needs that we are not able to communicate in the industry language. Tick in that box. Some providers don't need to know we are a research institute, as it acts more like business to consumer transaction. Might be a challenge, I agree. Yes, dealing with administration seems to be complicated at first, till you find your way in this culture and it becomes simpler. Yes, I've been here for 6 years and it's still challenging, I tell you. So yes, from RI point of view, we can sometimes over-ask difficult for small and medium enterprises to cope with. Yes, indeed, and that's a lot of feedback we do get. Yes, we are special course. We talk in another language than logistics providers, especially in our needs and demands, which are sometimes out of the ordinary. Indeed, they are, and we have seen many examples of that during the day, where we're not shipping square boxes. I experienced that it takes open-minded people to understand what the needs of the RIs are. Here, I agree. Explaining the need of cold transport can be difficult for logistics providers. Yes, totally agree. A way to simplify relationship with RIs is to set up routine meetings with a regular frequency. Good input. Special, we deal with products with us special in handling and transport, nothing out of the shelf. Totally agree. But we have a mix as well, but the challenging part is, of course, not off the shelf. Sometimes I expect their experience is that scientists are very good scientists, but not necessarily skilled in logistics, can be considered unorganized. We can't be best on everything at every specific time, so okay, duly noted. There are experts for everything. That was good input, and I think we can have that hanging on our wall to remind us that perhaps we speak Greek to some extent when it comes to logistics from a science perspective. Perfect. The third question, Cassandra. So, as is, we have the organizing committee, which Ute presented with a limited amount of RIs. There are a lot of other RIs out there, both within Europe and outside Europe. And of course, if we are going to approach authorities and create standards, it's better if we are more. So how could we attract them to make this a success in the long run? Because hopefully we are not, we are not strong in fighting our own wars individually. We could actually join forces and win some battles, because that will be a good way forward. Advertise it more widely. I only learned about this conference by coincidence because a colleague mentioned it. Word of mouth, that's good, but not effective. Yes. Be more visible, more advertisement. Okay, we need to reach out through the internet. Good there, Kitty. Access to common support infrastructure and best practices. Yes, Showcase the success achieved so far. Concentrate on low-hanging fruit to demonstrate the value. Yes. Proactively contact platforms that already represent a group of RIs. More happenings like this one. Yes. Perhaps with another agenda, which is more to the point. This was a broad one. Let's see what happens, but it's good input. And perhaps we will have the IRO forum knocking on the door after this presentation. We'll see. Share experience where at the end we all benefit from, like today's event. Yes, perfect. We need to create some experience and some success stories. So that's correct. And this event is actually the first step. Perfect. I really like the feedback. So this was the last Menti question. It's 16:50. I actually do have some questions from the Q&As. If you are ready to just ask a question before Ute comes in, you want 3 minutes to the end? Yes, perfect. Then I would like to ask Ben. You showed a picture with all the bridges and roads and special solutions. Was everything in place when you pulled the trigger, or were you plan as you go?
No, well, the agreement to choose the site in it was signed in 2007. You can see that we only started working on these roads. Well, the first start was already in 2008. So yes, it was on the critical path, as you can imagine. But at the same time, when you start detail designing ITER, that also takes time. So we were in a good shape because we were not the only critical activity. And we had the French government, who is responsible for the implementation of these measures. They didn't want to lose face with such a project in their country. And then there is Europe that is paying for the use of this itinerary. So yes, there was a strong commitment and support from the French government, which made it, I won't say easy, but well, it helped a lot. There was a big project behind these also expensive and bureaucratic changes, but we managed.
So we call you had leverage, and that's good. Perfect. Terje, a question for you. I really loved your presentation where you had this supply chain, where you have all the actors and key operational challenges. What was the greatest challenge to complete this supply chain as you deliver it today? Is it a self-developed thing, or is it off-shelf products, or?
It's a good question, because we thought it in this big logistic world, it should be possible to purchase a shelf product. But based on the fact that we sort of turned the value chain upside down, it was difficult to find it. So yes, we have developed our own, and you know that's normally a suicide for a small company as ours. But we were very focused on using a very well-known platform, so we ended up at the Microsoft CRM. But it works good.
Impressing, and the thing is that, coming from industry myself, it feels like it's the customer in focus, and it's really really good work there. I have a question, or rather, you already answered the question, Inger, because the next question was for you. What kind of tools do you have? And you answered in the chat, but you can also elaborate on that now.
Yeah, so I think actually that's one of the failings of the current system we have, is we don't have a lot of good tools to use, and it's very confusing for the scientists to know how to access the services. And this is what we want to work on. But one of the tools that we did develop, as I mentioned in my talk, was this notice board where people can share information about their fieldwork plans and then offer some of the spare capacity that they have. And this has already been used to quite good effect. We opened it during the pandemic. It was already on the cards, but actually during the pandemic, it became even more useful, as we saw in my little video clip, because people aren't able to travel. So that was the kind of main tool that we have so far, but we really want to work more on better coordination.
Perfect, thanks. And Cedric, I think there is one question for each of you. Cedric, when you showed the roadmap for Lean, you also pointed out a lot of systems that were, interacting. How much of that is off-shelf and or developed by CERN?
Yeah, we purchase a development for a tracking tool, and then we have also internal IT teams doing the integration with the ERP. Of course, initially we bought something which was out the shelves, but then the company just stopped after 3 years, so we had to move it to another company. But there was a simple tracking system through phones using the image technology to detect a barcode, so very classical. And then everything is in CERN systems, I would say, using our internal IT, and then we build dashboards based on that. So
and everything is integrated, yes?
Yeah, it's all integrated, yeah.
Amazing. That's how you run a small town.
Hopefully.
Hopefully. It looks good. Francois, you seem to have all
Yes,
the systems in place, but how many people do you have behind the scenes supporting Ben in his challenges?
I mean, for the IT or
No,
global
for the
ITER?
total, no, for the ITER project.
For the project, yes, today we are 70 people on site, 70. We decided to join the site. We were remote previously, but we felt that it was much better to be part of the family and to share daily routines and daily discussions and meetings with our colleagues and clients. So today we are 70 working for ITER in France, plus all our partners or agencies over the world. But right, full-time dedicated to ITER, we are 70 here.
Are you integrated in the ITER organization, or are you running your own?
No, we are fully integrated. I'm talking to you from the site here today in my office, ITER sites, and we are fully integrated. And we are even paid through management fees by ITER, which is quite, I feel, a nice, clever, I would say, move. Because we don't talk about money with it. We are paid through management fees for this team. And then we have what's so-called profit fees on the top of that to make the profit for the company. And everything is clear and discussed every year as on June, and implemented in October for the next year. So depending on the activity and flows through KPIs, we can have straightforward discussions with Bentley around the table here and ITER to mobilize resources for the year after.
So kind of an open book, so to speak.
Open book, absolutely.
Perfect.
Absolutely.
Perfect. So I'm extremely happy for all the answers and for the participation and grateful for the input from the audience as well when it comes to the Menti. That ends my session, and you're pinned.
Yes, thank you very much, because now I'm going to introduce the evening entertainment to everyone. So that has been a very long and very informative day, and I guess now it's time for some pleasure. And this pleasure will take us to the top of the world that Terje and Inga have introduced to us already. So what we want you to do is that you rejoin again at 7 o'clock, but you will get a different link. At 6 o'clock, we will send out a link to you that is an open Zoom call where all the participants are asked also to open their screens, because what we want to do tonight is we want to have dinner with you. So now we've sent out, and this was our logistics challenge, and some of us, let's say, were happy to receive something, others didn't. We sent out boxes with food and wine in it. My box, unfortunately, or not my box, my wine bottle broke, so I have to go now and buy a bottle of wine because I only got the cheese. Everyone else should have received a box with some food for those who registered early, and some of you also received some vouchers to order something online. For those who haven't received anything, get your food, get your drink, and join us at 7 o'clock. And then we'll have some local entertainment, Inga, right? And I mean, this is the time now to tease everyone to come back at 7 o'clock and listen to the choir. Inga?
Yes, we have a couple of very nice songs from our local choir based here in Longyearbyen. It's a men's choir that's had a long history in Longyearbyen, and we'll hear a little bit about them, and then they'll entertain us with a nice song and hopefully with a nice sunny background.
Fantastic. So I'll expect everyone to be back here at 7 o'clock. Get ready and get your drinks and food in place, and see you then. And thank you very much for being with us throughout the day. See you later.
Thank
Bye.
you.